Modeling, Topic 13, Forward Contracts, Section 5. We're going to simulate cross-hedging strategies using correlated randoms in at-risk. So in the last section, we said that Southwest Airlines wanted to hedge 100,000 gallon purchase of jet fuel using a forward contract on 100,000 gallons of jet fuel, and their risk was eliminated. However, let's assume there was insufficient liquidity in the forward markets to get the jet fuel contracts. And what they attempted to do now is they're going to cross-hedge by purchasing 97,190 gallons of heating oil in the forward markets. And you can refer back to the earlier section of how to get that optimal hedge quantity of 97,190. So what we're going to do is we're going to add this hedge to our spreadsheet. And we're going to simulate both the price of jet fuel, which determines the cost of fuel to Southwest, and then simulate heating oil that determines the payoff of the forward contract. And what we're going to do then is then look at the total hedge position using the cross hedge. Now to add a correlation, to run the simulations on both heating oil and jet fuel, if I don't specify a correlation for those two variables, at risk will determine, will implicitly assume that there's zero correlation. In other words, they're independent random events. However, they're very highly correlated, 97%. So on any given day, when one is up, the other one tends to be up. So we need to build in that correlation into the random variables in at risk. And I'm going to follow these steps. So I'm going to go to my spreadsheet. I'm first going to add the heating oil simulated price. I'm going to assume that heating oil is currently selling for $1.60 in spot markets. It's expected to appreciate 5%, just like jet fuel. However, I'm going to have a random variable, risk normal 0.1 times the volatility. And I have the volatility of heating oil calculated earlier. So this is my simulated value for heating oil. Let's assume that they were able to get a forward contract at 168, the expected spot. And now we have the profit or payoff of a long forward on heating oil, which is the simulated price, the simulated heating oil price. That's right in this cell here, minus the forward price times a quantity of 97,195, which is the optimal hedge quantity. I then add that forward simulated profit from heating oil to my unhedged jet fuel cost simulation. And now this cell here simulates Southwest Airlines exposure to jet fuel plus a hedge on heating oil. I'll then run that 10,000 times. Well, I can't do that. If I run that 10,000 times, the random variables for heating oil and the random variables for jet fuel will be uncorrelated. In other words, independent random events. What I need to do now is add a correlation matrix or a correlation value to those two. Now I do have a correlation matrix that I calculated earlier. The correlations between heating oil and jet fuel is 0.97. What I'm going to do is I'm going to add this to at risk. So what I'm going to do is go to my model window in at risk, which shows me my inputs and outputs. I'll go look at my inputs. These are my two inputs. Looks like A8 would be the random value for jet fuel. A36 is the random variable for heating oil. I'll then hit right click and correlate and create new matrix. Now if that had more than two variables, I have to make sure that these are in the right order, but I don't. So now what I could do here is I could simply just type in my 0.9734, but I'm going to do this. I'm going to do a right click, copy coefficients from Excel. I want to tell at risk that these are my values. hit OK, and I'm going to hit OK a bunch of times. This is just a problem with Penn State's security software. I'll hit OK a bunch of times. And looks like my correlation was taken, 0.97. I'll hit OK. Whoops, I need to specify one more thing. I've got to hit OK a bunch of times again. I need to just give a location in the spreadsheet for the correlation matrix that at-risk will actually use. I'll just put it here. Hit OK. Now this is the actual correlation matrix that at-risk will use to generate those 10,000 random prices for heating oil and jet fuel. I can now run my 10,000 iterations and it will simulate correlated random variables. And what you see is the risk is still present. There's some risk left because they're not perfectly correlated. However, my exposure now is my 90% confidence interval is between 154 and 161. 154 and 161. Now, if I was unhedged, my risk was between 140 and 170. So I was able to, and had a standard deviation. The unhedged exposure had a standard deviation of $9,800. My now using the cross hedge, my exposure is only between 153 and 161, 90% confidence interval, and my standard deviation is only $2,200, which is 23% of the original exposure. So I'm able to eliminate 77% of my exposure. Theoretically, that should have happened. If I take the square root of 1 minus the correlation squared, that should tell me the percent of the risk that will remain after the cross hedge. Now, I'll just give you an idea. If I were to change this correlation to 0 or not put the correlation in at all, I would have had a lot more risk. So by putting in this correlation of 0.97, it's simulating that these two variables go together and the cross hedge should be effective. So in this topic, we calculated our cross hedge and simulated both heating oil and jet fuel using correlated randoms in at-risk.